To get a better idea of what's happening, we'll measure in degrees centigrade instead of degrees Kelvin. Already during compression, the temperature reaches the melting point of lead. During the first part of combustion, the temperature reaches the melting point of aluminium. Shortly after that, the temperature reaches the melting point of cast iron. The high temperatures in the cylinders even exceed the melting point of steel. Combustion takes place so quickly, however, that there's no time for the high temperature to be transferred to the cylinder wall. The temperature of the metal surfaces will not exceed the mean temperature of the process, about 620 degrees centigrade. Then again, the cylinder's made of cast iron, which begins to lose its strength at already around 300 degrees centigrade, besides which the lubricating oil will lose its lubricating ability if it becomes too hot. It's therefore necessary to provide efficient cooling, partly with oil led through the piston rod up into the piston itself, and partly with water circulating through the cooling jacket around the cylinder and cylinder head, and passing rows of narrow drill channels placed close to the most heavy, heat-loaded internal surfaces. If a cooling water outlet temperature of about 80 degrees centigrade is maintained, we can prevent the temperature on the inside of the cylinder wall from exceeding 300 degrees centigrade. This is possible because there's a drop in temperature as the heat passes from cylinder gas to metal. Even though the gas is in violent motion inside the cylinder, the boundary layer close to the wall forms a rather effective insulating layer where the temperature falls rapidly. Through the wall itself, the temperature falls evenly, but the heat transfer to the cooling water is controlled by the local boiling point of the water in contact with the wall, the so-called micro-boiling phenomenon. The high wall temperature causes a local boiling, which is able to absorb relatively large amounts of heat. Small steam bubbles are formed, which immediately break loose from the surface and condense in the surrounding water. Due to this, the wall temperature is almost independent of the transmitted amount of heat, provided that the water temperature is safely below its boiling point. With a mean gas temperature of about 620 degrees centigrade and a cooling water temperature of about 80 degrees centigrade, it's possible to calculate a thickness of iron that offers the same resistance to heat flow as the boundary resistance between cylinder gas and cylinder wall, and similarly a thickness of iron that corresponds to the boundary resistance between cylinder wall and water. As the drop in temperature through the entire homogeneous iron wall will occur evenly, the temperature of the original cylinder wall can be determined. 3 temperatures, which are calculated for the hottest point in the cylinders, explain why the material cylinder walls are able to withstand the high combustion temperatures.